So before starting this video, let me tell you, if you have any doubt regarding this question or any question, you can contact me on Instagram, or you can join my Discord server. I provide both the links in the comment section. I will pin them. So in this video, I'm going to discuss the GFG Weekly 83. This question, most and least tasty, which is the second question and contains 35 marks. It states that you're given a number n equals to 4, that is an array of size n, and you are given k equals to 2, that is you can divide this array into two parts, that is k parts. And what you have to find out, if that is there are many possibilities of dividing this array into two parts or k parts, okay. And after done, you have to add all the left and right elements of those partitions, okay, all the left and right elements of those partitions. And you have to find the difference between the maximum possible such result and the minimum possible such result. I will explain it to you. So 1 2 3 1, okay, 1 2 3 1. So it can be divided into two parts by 1 and 2 3 1, or 1 2 and 3 1, or 1 2 3 and 1. Okay, so there are three possibilities. In this case, this is the left and right elements, that is of this partition. The left and right elements are 1 plus 1, that is 2, and in this element 2 plus 1, that is 3. In this element, in this 1 plus 2, that is 3, and 3 plus 1, that is 4. In this 1 plus 3 is 4, and 1 plus 1 is 1. So plus 2 plus 3 is 5, 3 plus 4 is 7, and 4 plus 1 is 5. Now what is the minimum among them? 5. And what is the maximum? 7. So 7 minus 5 is 5 6 7 2. So the answer is 2. In this case, you can see, I think okay, I will directly go to the pseudocode, and then I will explain how to do that. Okay, so one simple intuition about this is, no matter how many partitions are there, the first and the last elements are always counted. Check in this. 1 is always counted, and this one is always counted. This one is always counted. This is always counted. This and this are always counted. So the basic thing about, okay, first of all, the base case, that is if k is equals to 1, that is there are no partition, it is the whole array, then return 0. Okay, because the maximum and minimum will be same. Then we have to run a loop from I is equals to 0, I less than n minus 1, I plus plus, and AR of I equals to AR of I plus AR of I plus 1. Now why I am doing this? So we know that in every case these two are there. So in this case these two are there, and what is extra? That is 1 plus 2, that is the where the partition is there, the element before this and the element after this. So in this case, what is extra? 2 and 3, that is 5. So see, 1 plus 1 is 2, and 2 plus 5 is 7. 1 plus 1 is 2, and 2 plus 1 is 3. So 3 plus 2 is 5. 1 plus 1 is 2, 3 plus 2 is 5, so 5 plus 2 is 7. Now in this partition, this and this element, so 3 plus 1 is 4, and 1 plus 1 is 2, 4 5 6. I'm really sorry. So this shouldn't be 1. Okay, this should be 1 plus 2, that is 3 4 5 6. No, this should be what it should be, 1 2 3 1. Oh no, this should be 1. This should be 1. So okay. Where did I go wrong? Okay, so 1 plus 1 this should be, okay, 1 plus 1, that is 2. Okay, that is this should become 6. This, I'm really sorry for this. So for this, so 3 plus 1, that is 4, and 1 plus 1, that is 2. So 4 plus 2 is 6. Even if this is 6 or 5, the minimum will be 5 and the maximum will be 7. Okay, so the answer doesn't change. So what we have to do, we have to find out all the values of AR of I and AR of I plus 1. That is, we are modifying this array as AR of I equals to AR of I plus AR of I plus 1, and the last element we are making it minus 1, and then we are sorting in this array. Okay, then we are sorting this array. So in the minimum, so first of all, k minus minus, because the number of partitions is actually 1 plus the number of borders. Okay, so if there is 2, if k is 2, that is there are 2 parts, then the number of borders is 1. I meant it. So if k is 3, that is 3 parts, then the number of borders is 2. So that's the reason why I'm doing k minus minus. This is borders. Okay, this is borders. So now we have to run a loop from I is equals to 1 to I is less than equal to k, that is the first k borders, and sum 1 plus equals to error of I, that is the sum of first this numbers, which is the minimum sum, and the last k numbers, which is the maximum sum, that is n minus 1 greater than equal to n minus k I plus plus, I'm sorry, not I plus plus, I minus minus, and sum 2 minus sum 1. We have to return sum 2 minus sum 1, that is maximum sum minus minimum sum, and that is the answer. So in this case 1 2 3 4 5. Okay, so first of all this gets overwritten as 1 plus 2, that is 3, 2 plus 3, that is 5, 4 plus 3 7, and 5 plus 4 9, and the last element is minus 1. So after we sort this, it becomes minus 1 3 5 7 9, and k was 2, and k minus minus, in this case k minus minus becomes, so that k becomes 1. Okay, so k is 1. Now check this out. We are not considering this case, that is minus 1 we are not considering, so we are starting from here. So what is the sum of one element from here? That is 3. Okay, and what is the sum of one element from here? That is 9. So 9 minus 3 is 6. So what are we returning? 6. In this case 1 2 3 1, let's do it real quick. So 1 plus 2 is 3, 3 plus 2 is 5, and this is 4. Okay, and this is minus 1, we will not consider this. First of all, let's sort this, and k minus minus, so k is equals to 1. So this is 3 and this is 5. See this, 3 and 5, right? So 5 minus 3 is 2. This, if you add 1 and 1, that is 2 to this, okay, to this, so that becomes 3 4 5, 4 5 6, and 5 6 7. See, 5 6 7, that is 5 6 7. So we are basically finding out an array. This is a very simple method. This is occurring in big O of n. This is a very simple code. This was a medium level, very nice one. Thank you. This is the pseudo code. Okay, thank you.